Hello everybody, welcome back to Space Engine. I'm gonna try to actually fix the volume this time, because apparently my videos are very quiet, which actually makes a lot of sense because I operate everything really quietly. Like honestly, my computer volume is always at the absolute minimum. It's at 4 points at all times, and I never bring it up beyond that. Even my TV, I usually watch it at volume level 3 or 4. I don't know, I just don't like loud things, personally. So everything's quiet. But apparently I'm very quiet, so I'm actually going to try to talk louder this time, without irritating my, anyone who lives here. But, yeah, I'll also check and level it. To me, the video seems fine, but apparently I'm very, very quiet. Anyways, we have a full itinerary. That one star that I couldn't find, I'm going to try it again. The fellow clarified it. Thank you very much. And Gallifrey, apparently I was given the wrong number. And basically it was like dialing someone, but then you end up talking to some random stranger and you make fun of them. That's kind of what happened in that case, only instead of a random stranger, it was a random planet and not Gallifrey. 8409-656-5-27912-51. Object still not found. 1251 5 656 8409. This. Oh, okay. Let's try that again then. RS. Let's try it without any spaces. 8409 dash 656 dash 5 dash 27912 dash 51. Let's put the space there. No, I'm terribly sorry, but I can't actually find this place. No matter what I type in, it's not working. Maybe the RS has to be lowercase. I don't think it does, but I'm going to try it anyways. No. That is okay. I don't know. Maybe take a picture of it and screen cap it to me so I can see for sure. I honestly don't know. I can't get it to work. It's not working. Which kind of sucks. You say it's pretty, and I like looking at pretty things. And I really want to see it, but I can't. So yeah, seriously, if you can, send me a screen cap of the planet. Make sure the name is in the side there. Because I can't find it, and I want to see it. I want to experience this. Anyways, let's go to Gallifrey. HD 106906. Ah, there we go. Actually, really amusing, because every time I've made these videos from day one, whenever I take suggestions, I'll grab a random piece of paper and write down a list of today's episode's locations. And as a result now, my desk is full of just a bunch of scraps of paper that have random numbers and planets written on them. Like this one here, actually, I've had things written on it twice. This looks remarkably familiar. Gallifrey, you're still the wrong color. 106906B. Yeah. You know what? Just 1 second. Right, I can confirm that is the correct number. Apparently, they did find a quote-unquote Gallifrey-like star. Unfortunately, the star is, as it's shown here, it is massive, it's larger than Jupiter, it's a gas giant, and in no way is it like Gallifrey. I have no idea. I didn't really read further beyond that. I have no idea why they're calling it Gallifrey. Because of last time, I may be wrong, but Gallifrey looked rather terrestrial in Doctor Who, and I didn't turn my stopwatch back on. Oops. Oh, whatever. Resume. There we go. So yeah. Hmm. Oh. Oh, okay. We're just in the atmosphere now. Let's get the fuck out of here. Right then. I guess we're gonna leave that behind. The galaxy. It's just so beautiful. And it's Andromeda. But we're not talking about Andromeda. We're talking about the Milky Way. Actually, in the Star Trek universe, Andromeda is inhabited by assholes. Seriously. There are so many, especially in TOS, there are so many just, like, evil creatures that come from Andromeda and come here to start something. The Kelvins came from Andromeda, and they were gonna, like, conquer the galaxy. I forget what they were named. Those two little creatures that were posing as sorcerers from a Shakespearean play, they were from Andromeda, I think. And, I don't know, it's just like, Andromeda's inhabited by assholes, apparently. But apparently it's also dying, because, like, of radiation, so, whatever. Karma, bitches. Actually, the Doomsday Machine came from another galaxy, but they never indicated exactly what galaxy it came from. And the giant space amoeba came from another galaxy, but they never, again, specified which galaxy. So I'm just going to blame that both of those came from Andromeda, because, again, Andromeda's full of assholes. Yeah, let's find more stuff. And those little... No, those... Oh, shit. I wasn't paying attention. That's why I can't have nice things. Those little bug thingies from the first season of TNG that would, like, take over people's brains and were trying to take over the Federation. Oh, there we go. Those came from... No, those came from a planet within the Milky Way. They're local assholes. Let's go. And I guess the Borg were from the Milky Way. They're from the Delta Quadrant. And they're assholes. This is... Looks kind of like, well, a paler Eve, I suppose. Right then, let's look at some information on this here planet. Info. Boop. No, stop. General. We have a temperate terra, organic multicellular, a biogenic, and it's marine. Physical characteristics, it is, where's its age? Ooh, it's younger than the Earth. That's interesting. Its solar day is 21 hours. Okay. What is its, where is it? Mass. Oh, okay, it's similar. Density, temperature effects. Orbital, there we go. Let's check the atmosphere. Right then. The atmosphere is composed primarily of oxygen. That's interesting. Carbon dioxide, sulfur dioxide, hydrogen sulfide, water, CHH2, that's C2H6, C2H4. Are those like the there's argon, but those are like ethane and methane and acetylene? Pretty sure. Anyway, that's quite interesting. But primarily oxygen, that's an interesting atmosphere. Well, I was about to say, it's like, if we were to breathe this, well, we'd probably die because of the sulfur dioxide and the hydrogen sulfide. So, well, they're not in terribly high amounts, but still it's high enough. But, what prompts us to breathe actually isn't oxygen, it's carbon dioxide. If you were in a completely, pure oxygen environment, you would actually stop breathing, and you'd die. Like, seriously, it's an interesting fact. Also, oxygen under pressure is poisonous. So, like, if you're in a pure oxygen environment, or if you're breathing oxygen, pure oxygen, and it's higher than normal atmospheric pressure, it actually becomes poisonous and you die. So don't do that. Oh, I almost screwed that up. Oh, what's new in the world? Is this the same planet? Did I just come back here? No, this is a different planet. Oh, Elon Musk talked about his plans to colonize Mars, which were pretty damn cool, actually, I'm not gonna lie. I love Elon Musk. He's my spirit animal. Um, I also really, really, really appreciate, I cannot emphasize this enough, I so love how his interplanetary or colonial transport looks like a rocket ship from a 1940s science fiction. Like, seriously, if you look at it, it is literally just like a spaceship that you would find in, like, Buck Rogers. That made me so damn happy, because I've always talked about how I love, like, the retro futurism thing, and how, like, I miss that type of thing. Like, nowadays, science fiction, they try to make their ships all, like, realistic, and they look, like, modular and bulky, and that by itself has its own charm, but there's something about the retro future look that was just so damn nice. All those sleek lines and goofy looking spaceships, all those really alien looking landscapes with the jagged rocks and the arches and the mountains that look sculpted like clay and not. It's just I love that so much. So that made me really happy. Mostly carbon dioxide. Lovely. So that's exciting. And actually, it was really interesting because his announcement has kind of started the whole debate amongst these, two factions of people, and there are two of them. You have the people who say we should stop wasting money in space exploration and try to fix this planet, and then you have the people who are saying we should stop wasting money trying to do environmental stuff and just get off this planet altogether and save our species elsewhere. And I'm sorry, but both of those camps are wrong, and that's just how it is. They're both wrong. The hell is that? Like a pine tree floating in space? Because it all comes down to they're both wrong in that they're both right, if that makes sense. No, it's a nebula. It's like, for one, we do need to push out into space and to colonize other worlds and basically extinction-proof our planet. And I'm doing hand gestures while I talk, which I shouldn't because I'm supposed to be using the keyboard and mouse to do interesting things. So it's like we do need to do that. However, there's nothing saying that we also have to maintain this planet and we have to try to undo some of the damage. And both options can be done. Like, it isn't a one or the other. I'm not going to say it's easy. It's not. It's very much not easy, but it is doable and it is realistic to imagine a future where we both have off-world colonies and a space infrastructure, but our home world is also environmentally not under severe threat 24/7. The biggest problem nowadays, I guess, is atmospheric carbon concentrations, and then the greenhouse effect. Then it hits a certain tipping point, and then it warms the atmosphere enough that allows more moisture to get into the air, and then the more moisture that's in the air, water vapor is a huge greenhouse gas that makes the air hotter, and then that makes more water in the air, which makes it hotter, which makes more water in the air, which makes it hotter, and it goes on and on and on until the ice caps melt and Florida disappears, which I know the idea of Florida and some of the southern states being flooded and, basically being washed away and all that sounds like a really great idea, but in practice it also means that other non-horrible places are also getting damaged, and that's not a good idea. If you're from Florida, I'm sorry, but that state really is terrible. You can't deny it. That's not even my opinion, that's just everybody's opinion. Even people who live in Florida think it's terrible. I never want to go there, ever. Ooh, through with life. But, again, there are options available to us. First off is reducing our dependency on fossil fuels, which is the biggest one. Now, that doesn't mean that we have to stop using oil altogether, because you have to understand that oil and petroleum aren't just used as fuel, they're also used in manufacturing, so it's a terrestrial unicellular of life. Let's check its atmosphere. We have, it's panspermia, which makes sense, there's multiple life here, and it's organic. What's the atmosphere looking like? It is mostly carbon dioxide with a bit of sulfur dioxide. Alright. Now, what was I talking about? Saving the world? Petroleum, that's right. Because petroleum is used in basically everything where you make any plastic product. Most polymers use petroleum. Lubricants use most lubricants use petroleum. Basically, right now, I can guarantee you are holding or looking at something that has a majority petroleum products in it. Like, for example, my keyboard and computer are almost entirely made of, well, plastics, beyond the electronics, which means that it's made of mostly petroleum products. So I'm literally playing games on a dinosaur box. Yes. Actually, that's also not true. Most oil comes from algae and plankton that built up over time. Dinosaurs make up a very small amount of that, which when I first learned that was very, very sad. Panspermia again. Some people are sharing. Atmospheric, mostly hydrogen. That's interesting, actually. Aerial organic. So it's like we can't stop using petroleum 100%. Not right now, anyways. There are other alternatives to petroleum in polymer production, but it's unrealistic to think that we have to stop using petroleum 100% right now. However, it is realistic to assume that we can stop burning it. That is realistic. We can stop using it as fuel. We can stop making gasoline. Seriously, we can. We need to at some point. Info. This is abiogenic. So this is probably where all the life began in the solar system. Interesting. What's its atmosphere? Mostly oxygen. Each one of these planets has a completely different atmosphere. That's interesting. So it's like we need to stop burning it. We really, really need to stop burning coal. That would be wonderful. The thing about coal burning is it doesn't just produce carbon dioxide. One of the biggest problems, in my mind anyways, that coal does is burning coal actually does produce radioactive waste. I know it sounds weird, but when you burn coal, it actually dumps a fair bit of radioactive isotopes into the air, and it also produces metallic particulate. It actually really sucks for me because I like to lay stuff out in the backyard and front yard or anywhere and collect metallic debris falling from the sky. God damn it, looking for shooting stars. However, because there is a coal plant, I think there's a coal plant in the city. I know a lot of our power comes from wind here, but I know we do have a coal plant somewhere, and because of that, I can be guaranteed that a lot of the particulate that I find is actually coming from the coal plant and isn't extraterrestrial in origin, which really also is disturbing because it's like, wow, okay, so there's metallic particulate in the air from burning coal. Info, general, abiogenic, marine, multicellular, organic. What's its atmosphere? Mostly oxygen, bit of nitrogen. I mean, it's mostly carbon dioxide with a bit of nitrogen and then a little bit of oxygen. So it basically has, oh, there we go, and sulfur dioxide and argon. So it actually, in terms of the gases, it has a similar atmosphere to Earth. In terms of the ratios, it is very, very different. Because here on Earth, we have around 70% nitrogen, and then a small percentage of oxygen and carbon dioxide, and then argon and whatnot, and water vapor, actually. Actually, it makes sense that we have water vapor on our planet, because we have a lot of water on our planet. I am quite fond of this planet. Please stop killing it. So yeah, it's like we do have options available in those regards. We can at least mitigate for now. Stop burning it. Actually, the thing is, if we stop burning coal, but still allowed cars to go on, even that would make a significant impact in reducing carbon emissions and pollution. But honestly, we really need to stop burning gasoline for fuel. There are some things, like, I don't know, kerosene and like other petroleum burning fuels will probably still be produced for various reasons. But there's a lot of things that we really need to stop doing. So it's like we do need the oil industry, however we need it for polymer production and like basically infrastructure stuff, whereas we can use power in other areas. And this also is why going to, spreading out into space is also an important thing, because as I've said, in many times, one of our, like the saving graces of our species would be helium-3 fusion, because you can generate a lot of power that way anywhere, even even in places where solar and wind aren't practical, and you need nuclear power plants. You can use helium, you can use a fusion reactor anywhere, generate lots of power with no carbon production, and actually no radioactive waste either. However, currently on Earth, let's check the general, abiogenic, aerial, atmospheric, mostly gonna be, yeah, it makes sense. The thing with fusion is here on Earth, we could easily do deuterium fusion, because you can produce the fuel from seawater, more or less. However, deuterium-tritium fusion, it produces neutrons. It produces neutron radiation, which not only does it make that a little less efficient because you have energy being lost as free neutrons, it also, neutron radiation is, well, it's an ionizing radiation and it's very poisonous. It doesn't linger, mind you, like once you turn the reactor off, the neutrons go away and it's perfectly safe, but you'd have to have shielding around the reactor while it's running, and that's just a real pain in the ass. Because neutrons, you can't shield them with like lead and stuff. You need to use heavy, like stuff that have a lot of hydrogen in it, so really thick concrete or boron or even paraffin wax actually kind of works, or even just heavy water itself. Deuterium oxide can be used as a where's deuterium? No, it's deuterium monoxide because there's one oxygen. Heavy water. But it's a real pain in the ass, whereas helium-3 fusion produces no free neutrons. It just produces energy. It isn't, it's, I think altogether it's only, how efficient is it? I know that it's way more efficient than any current power generating like facilities. In terms of like atomic energy, like using the actual energy equivalent of the atom, I think deuterium fusion is only a few percent efficient, which there we go. Which doesn't sound like very much, but if you think about it, burning coal is like 0.00000 something percent efficient in that regard, because it's terribly inefficient. And fusion is actually a percent point above 0 point. Antimatter fusion is actually like almost 99%, is almost 100% efficient. It actually can be 100% efficient if done correctly, but utilizing the power 100%, you can't really necessarily do. Anyways, let's go here. And the reason why we can't just do large-scale helium-3 fusion right now is because helium-3 is not readily available on Earth. In fact, helium itself is not readily available on Earth. Come on. No, stop that. Where is the planet that has life? Oh, I think I screwed up and clicked on the wrong star. Come on. There we go. However, helium-3 is found in a fair abundance out in space in various locations. The closest source is the moon. But you have to dig through a lot of regolith to get it. Because, the solar winds is actually helium-3 in the solar winds. Because the sun kicks off a lot of stuff, and it gets embedded in the regolith in the moon. So you actually can get a fair bit of helium-3 from the moon, but you have to go through a lot of material, and it brings up efficiency issues. Like, you're using up more energy than you get from the thing, and it becomes inefficient. 99% general, abiogenic marine. But it's better than nothing. If you can do it efficiently, go for it. The biggest sources of helium-3 are in the gas giants, actually. It's not telling me. Oh, it's from one of the moons, not the actual planet. I done goofed. The gas giants have the most abundance of helium-3, as you'd imagine, because they're mostly made of hydrogen and helium. Obviously, Jupiter has the most. It's abiogenic. Well, so life arose independently in two places. So Jupiter has the most. However, you can't really cloud mine Jupiter efficiently because it has a massive gravity well and killer radiation belts that want to melt your face. Saturn has a lot, but it also has a fairly steep gravity well. Its radiation belts are less face melty, but they're still there. Neptune, you can't because it has a lower gravity well, but it has the strongest winds in the solar system, and it's hard to maintain any infrastructure in the atmosphere when you have like 200 Actually, no, it's like 2,000 kilometer-an-hour winds trying to kill you. So this actually leads to Uranus being actually one of the best bets for cloud mining for helium-3 and other resources, because Uranus has a relatively low gravity well, so it's actually fairly easy to get out of, to get away from, and it also has very low winds, surprisingly. Info. Which is also why its atmosphere looks very uninteresting. It doesn't have a whole lot of cloud patterns. Like, even Neptune has cloud patterns and stuff, but Uranus, not really. Excellent. What's the atmosphere here? Mostly oxygen. Jesus Christ. And it's marine. It's probably a lot of, actually, wait here. Organic unicellular. Yeah, that makes sense. But say it's probably mostly, like, algae and, plant-based oceanic materials. So, yeah, Uranus is probably the best bet to go and get that. Saturn's a good place to go and harvest antimatter, because its radiation belts naturally collect antimatter from cosmic rays, but there's also interactions in its rings produce antimatter there locally. So you'd think Jupiter would be the best because it has the biggest magnetic field, but no, actually, apparently Saturn has the best concentration of antimatter, which is also good because Saturn has a lower gravity well and less face melty radiation. Earth also has a antimatter belt around it, but it's a very tiny antiproton belt. It's not really practical to harvest anything from there. Like, seriously, if you could get 100% of it, you might get enough power to maybe push a small spacecraft to one of the other planets, but it's not practical. You'd have to get like one of the, if you want to collect natural antimatter, you have to go to a large radiation belt, so a large gas giant, or one that has a big ring system. You could also make it, but that would require so much energy. You would need to have a, oh my goodness, you would need to have a massive, like, absolutely massive power system that would span thousands of kilometers in space, that either collects solar power or just uses reactors to just pump out nothing but antimatter, and it's very, not very feasible. Ooh, 26 minutes, although I think I missed a few couple minutes. Almost 30 minutes, alright, I should probably wrap this up. Ooh. But yeah, so that's where I stand. We're obligated to, both push out into the galaxy and spread ourselves, but we're also obligated to keep our planet, from dying. It's our home planet, for God's sake, show it some respect. There are some ideas out there, like carbon capture, where you just, basically capture atmospheric carbon and, either use it or just store it somewhere, and try to help, the natural carbon cycles, and all that jazz. And if you reduce enough of CO2 in the atmosphere, the greenhouse effect will drop. That's actually what they think happened. Actually, yeah, they think that's what happened in the snowball Earth era. It was like life started producing lots of oxygen and pulling out carbon dioxide, and so much of it was pulled out that the ice caps kept growing bigger and bigger and bigger, and then the ice caps reached a tipping point where they were so big, they reflected so much radiation that they started cooling off the Earth faster than the greenhouse effect was warming it, and it created this negative feedback cycle where it made the Earth cooler, which made the ice grow bigger, which made the Earth cooler, which made the ice grow bigger, which made the Earth cooler, and so on and so forth. And something's wrong here. Every time I go to, some stars, this happens. I don't know what the deal is. It breaks the entire thing. There we go. Nebulas? No, enable them. Yeah, some of these stars, I can't look at them. I'll have to, reinstall it then, I suppose. Or report it as a bug. And, actually, and then it was Snowball Earth was actually, because it lasted for a few billion years, and they think what stopped it was volcanoes. Volcanoes started pushing through the ice and started pumping out more carbon dioxide. Since there was no life that was open and active to absorb the carbon dioxide, the levels just kept increasing until they reached another tipping point where finally the greenhouse effect was stronger than the albedo effect of the ice, and then the Earth started warming and the ice started melting. And now we're in a wonderful moment where we're pumping out so much carbon dioxide that it's doing the feedback again. But we could theoretically capture a lot of it and, save the planet. But the atmosphere is very big. Like, on a planetary scale, it's small, but to us, it's very, very large, and significantly affecting its atmosphere. Although we've apparently been able to, in as little as 100 years, really pump out a lot of carbon dioxide. But bringing it all back in is more difficult, so... Again, there are ways. We were able to affect the atmosphere negatively in 100 years without even trying. So, with our more advanced technology and even trying, we may be able to affect it in a positive light, so... Again, optimism. Abiogenic. Lovely. What's its atmosphere? Mostly nitrogen. Ooh. We may actually be able to breathe this. 77% nitrogen, 15% oxygen, and a little bit of carbon dioxide, very small amounts of sulfur dioxide, and then everything else. We may be able to actually breathe this without dying. What's the pressure? Air density, kilograms, air temperature. Ooh, Jesus. Well, okay. It's very, very hot, but somebody's cooking something. The pressure's good, so the composition is pretty good, and the pressure is good, but it's very, very warm. Maybe near the poles we could probably survive. That might be good. Okay, I need to end it there. It's 30 minutes. It's a long episode, but people actually like this series, so I'm less inclined to worry about overdoing this series as other ones. People actually like it. So, yeah, thank you all for watching. I hope you enjoyed. Go plant a tree. Well, actually, on that point, there is an idea that I've been tossing around, but other people, it's not like, none of these ideas are very original, but it's like basically using carbon capture catalysts, where you basically produce a fleet of, well, actually, it's like either just like an artificial forest out in the middle of a desert somewhere where nobody cares, of large artificial trees that are basically just like carbon capture things, which some people are actually working on already. That they basically just sit up in this big area and they just capture a lot of carbon dioxide chemically. And there's other ideas where you use giant fans that actively pull air in and remove carbon dioxide. Or there's another idea I was kind of tossing around with, like, you can make catalyst balloons that are basically just giant blimps and stuff. And you just like make them cheap and easy and unmanned, and basically you just line the outside with a carbon capturing compound, and just have them float around, and just their surface area just collect stuff. It would probably need a lot of those with really efficient carbon capture, and you'd have to like replace the outer coating every now and then, just because. But hey, every little bit counts. Go plant trees, invest in green technology, and support both space exploration and carbon capture, because although the doomsayers say that we've reached a tipping point and we're all going to die, I say, no, we are not going to die. Our species is not doomed. We're in for a bit of a rocky future in an environmental level, but we can still, like, save ourselves and save the planet. We've reached a point now where a lot of species are probably going to die off, but the planet itself will survive, and the biosphere probably will survive too. And we honestly can make an effort to fix it, or at least mitigate it. So, yeah, we can do that, and we can save ourselves. We can make a better future for ourselves, our species, and the planet. I firmly believe that, and I firmly support that, because, again, the world is not, either it's ultra good or it's ultra bad. It's a mix of the two, and you have to find ways to make them work for you. So, yeah. Thank you all for watching. I hope you enjoyed that incredibly preachy message at the end, but thank you all. I like to say that. I'll be back with more episodes, probably more frequently, because I need to do that. That's all I have to say. Thank you for watching. Hope you enjoyed, and space.